Hello, welcome back. Today, we are going to continue our series on graphing rational functions. So this is for my pre-calculus students. Hello, and how are y'all doing today? Okay, so first, I'm going to give you an overview of the entire process. And then we're going to break it down one step at a time, one video per step. And then eventually we'll do a video where we do the whole thing. Okay, take a look. Okay, so here we have the entire process for graphing a rational function. And it may look a little overwhelming, but we're going to break it down. So today we're going to focus on step one, which is to fully factor the numerator and denominator of your function r. But while we're here on this page, let's just take a quick overview of where we're going next. After we factor, we're going to find the x-intercepts and the y-intercepts and identify wholes. We're going to use multiplicity to determine the behavior at those intercepts. We're going to find our vertical asymptotes, and those are from the zeros of our denominator. We're going to find our horizontal or our oblique asymptotes, and we'll have a whole video on that. We're going to perform a sign test to determine the behavior of our function as it's entering different ranges and approaching asymptotes. And then finally, we're going to take all of the info that we found from these first 6 steps, and we're going to use it to create our graph. And I promise I'm going to teach you how to do each one of these things. For right now, let's just go back up to number 1. Let's fully factor the numerator and denominator. So we're going to do 3 examples, but if you're feeling shaky on factoring, take a look in the comments. There are links to a few videos I've got that focus solely on factoring, so feel free to go and check those out too. So here's our first rational function. So we have a numerator and we have a denominator. It's expressed as a fraction, and that's what makes it a rational function. Now, if we look at our numerator, x minus 3, that is already factored down to its lowest terms. If we take a look at our denominator, we have an x squared term minus 16. Now that should be ringing some bells. If it's not, please go take a look at the video on factoring the difference of squares. But let's take a look at how we would recognize. First of all, we see a minus sign. That is a difference as opposed to a sum. X squared is most certainly a squared. It's right there. And 16 we recognize as also being a perfect square. That is 4 squared. So we have a difference of squares. And as you will recall, a difference of squares factors in the following way. Our x squared, the square root of that provides the first term for each of our binomials. The square root of 16, 4, provides the second term for each of our binomials. And then the way difference of squares winds up losing its middle term is one of these is a minus and one of these is a plus. And it does not matter which one is which. But you can see that as we did our FOIL, x times x gets us x squared. X times positive 4 is plus 4x. Minus 4 times x is minus 4x. And that's why those two disappear. And minus 4 times plus 4 gets us our negative 16. And then up top here, we have x minus 3 because that was already in its lowest term. So there we are. We've completed step 1, fully factor the numerator and the denominator. Let's take a look at another. So here we are. This is another rational function. We can see our denominator is already fully factored. That's just an x. Our numerator, we can see is a quadratic. And if you have not watched the video factoring using the x method, go ahead and take a peek at that now. But for those of you who have, let's go ahead and make our x. And you'll recall that the top is our coefficient of our squared term times our constant. So that's 1 times negative 6 or negative 6. And our bottom is our coefficient of our middle terms. That's a 1. And the question we're asking is what multiplies to the top and adds to the bottom. So we can go ahead and make our factor list. We have 1 and 6, we have 2 and 3, and that's as far as we go. So we can see the 2 and 3 are going to be the ones that are 1 apart. We need it to add up to a positive but multiply to a negative. So our bigger factor has to be the positive, and that makes this one our negative. And so our factor, because our coefficient of x squared is 1, that means these right here, we are all done. If the coefficient of this one is not 1, again, go take a look at the factor by grouping video. That will help with that. But when the coefficient is 1, these are our factors. So that means that on top we have x minus 2 times x plus 3 over x. You see that these plugged right in there. And this is our fully factored form. So we completed step 1 there. And let's do it one more time. All right, so here we've got a lot of stuff going on. Down here, we can see a quadratic. We know we're going to use our x method for that. Up top, we have an x squared, we have an x, but we don't have a final constant, which actually makes our lives a little easier. We don't have to do the x method. We could just factor the greatest common factor out of both terms. So let's go ahead and do that. 4x squared minus 4x, I see that a 4x is multiplied into both of those terms. So I'm going to factor it out. And 4x squared divided by 4x, I'm left with just an x. And minus 4x divided by 4x, I'm left with just a minus 1. Now on the bottom, let's make some room over here for my factoring by x method. On the top is 1 times negative 2 or negative 2. On the bottom is 1. My factors are just 1 and 2. I need it to multiply to a negative but add to a positive. So I need my larger one to be positive. That means my smaller one's negative. My x squared doesn't have a coefficient, so these are my answers. I'm done. And so in the bottom goes x minus 1 and x plus 2. And so this is my fully factored form. So I've completed step 1. Those are 3 examples of different versions of starting by fully factoring the top and the bottom. So take a look at those, practice those, and then if you feel like you're ready to go on, take a look in the comments for the video on the next step, which is to use what we just did to find our x-intercepts and our y-intercepts and identify any holes. Okay, I'll see you at the next video, and as always, keep mathing.